Welcome back to our second part of the binomial distribution from Chapter 5. We're dealing with parts C and D now, where we're looking at the actual probabilities. So we're expanding on the distribution, actually making a use of it that would be used in real-life situations. So part C, notice it says exactly 3. Not 3 or 4 or less than 3. The second one says no more than 2. So not just 2, but no more than 2. We'll look at those subtle differences as we go through this problem. So first of all, for part C, the probability that x equals 3. Using our distribution that we created earlier in part A, that's 20. Choose 3. So out of the 20 CDs, 3 of them were defective, times 0.005 to the third power, times 0.995 to the 17th power. Just to see how it looks with entry in on the calculator again. That would be 20. Choose 3 times our 0.005, caret sign for raised to the power, times 0.995 raised to the power 17 equals. And again, you see that 1.3086 times 10 to the negative 4. It's using that exponential. I would take the 0.00013 if you're going to go with those non-zero place values. For part D, no more than 2. Well, as you're looking at your values, 0 is not more than 2. 1 is not more than 2. 2 is also not more than 2. So 3 is more than 2. So the possible number of CDs would be 0, 1, or 2. So as you're looking at that now with making the calculations, you're looking at the probability that x is less than or equal to 2, which is the probability of a 0 plus the probability of a 1 plus the probability of a 2, which would be our 20. Choose 0, 0.005 to the 0.995 to the 20th, our 20 choose 1.005 to the first, 0.995 to the 19th, plus 20 choose 2.005 squared, 0.995 to the 18th. And again, you would enter that into the calculator just like for the prior example, prior part, just that you have to enter all 3. Again, make sure you're doing all of them, not just the 2. That's one of the common mistakes, is to just use the endpoint. This particular problem, it's 0.9999. not quite 1. If it comes out to be exactly 1, make sure you use an approximately equal to sign. If I were to round that to 3 place values, it would. That's approximately equal to the little squiggly line. 1, 0, 0, 0. Always use, I suggest, less than the 1, 0.999 in this case. So that's calculating probabilities then in the binomial distribution.